So today we're talking about 3.7, day 1. So make sure you put your name and date up at the top. Solving systems of equations by graphing. So we are going to come up with systems of equations. So we need to come up with some equations for these. Campground offers tubing, kayaking, bicycle rentals as shown. Write an equation to represent the total cost. So y is going to represent cost. So costs for renting a tube. A tube is $15 per hour, or $15, no matter what, plus $4.20, I'm going to drop the 0, per hour. Well, that looks a lot like y equals mx plus b to me, so I'm going to rewrite it like that. And that's exactly what it is. 15 at the y-intercept, 4.2 constant rate of change or slope. So I'm going to rewrite these other ones as y equals mx plus b. For kayak, costs us $6.50 per hour plus $25 deposit. For renting a bicycle is $7.50 per hour, so it costs $7.50 per hour plus $20 as a deposit. So they could have asked us to do some things with these, but they're going to do that later or tomorrow. Vocab word. 2 or more equations with the same set of variables are called the systems of equations. For example, y equals 4x and y equals 4x plus 2 together are systems of equations because they both have a y and they both have an x. You can estimate the solution of a system of equation by graphing the equations on the same coordinate plane. We're going to do that using y equals mx plus b. The ordered pair for the point of intersection of the graphs is the solution of the system because the point of intersection simultaneously satisfies both equations, or it works, it answers both equations. So there are some times where we have more than one solution. If the lines intersect, there's only one solution. So if they cross at some point, there's one solution, and it's going to be the ordered pair. If the lines are parallel, meaning they have the same slope, there is no solution. And if the lines are the same, which means M and B are the same, they overlap each other completely, there are an infinite numbers of solutions. So this is going to be our options today. You're going to either write one solution, no solution, or infinite. So practicing here, I'm going to graph these in 2 different colors. The first one, the y-intercept is -1, and we rise 1, run 1. So you can graph as many ordered pairs as you'd like. Sometimes it's kind of nice to graph more than one so that maybe you actually overlap ordered pairs completely. It's a little easier to see the ordered pair answer then. The next one has different slope, different y-intercept, so they should cross somewhere. This is a -2. Rise 2, run 1. So this one actually we see where it intersects, so I'm just going to add a few more ordered pairs to make my line a little bit easier to make. And our solution to this system of equation is the ordered pair 1, 0. So this has one solution, and it's at the intersection of 1, 0. On B, I'm going to graph y equals 4x. Well, that's 4x plus 0. So that says the y-intercept starts at 0, 0, 0, up 4 over 1, or down 4, back 1 from the original, since I can't fit more rising. All right. The next one starts the ordered pair at 3, or the y-intercept is at 3, and then it's up 1 over 1. So here again, you see that we overlapped, which is kind of nice when you put more than one, or more than 2 dots, more than 3 dots on your graph. You can kind of see exactly where it lines up. So I'm going to show you how this works. So the ordered pair 1, 4 simultaneously satisfies both equations. I read that to you, but what does that mean? That means if I plug in the equation y equals 4x and in the equation y equals x plus 3, I should get the same answer for both. X, y. So if I plug y should be 4, and 4 times 1, so I get 4 equals 4. Satisfies. Yes, it's true. This one, y should be 4, and x should be 1. That's 4 equals 4 again. So it simultaneously satisfies both equations. Works for both. So that's how we know it's the right equation. Now this graph is going to be really hard to see, but we can make it work. So graphing this one, y-intercept of 1, then rise 2, run 1, rise 2, run 1, or fall 2, go back 1. You can kind of see it. It's really, really light on mine. Should be better on yours. Okay. Now this next one is not in y equals mx plus b. I have to get rid of this -3. So I'm going to go ahead and add 3 to both sides. So y equals 2x, this is plus 1. That's my second equation. Look at my first equation. They have the same slope and the same y-intercept. These are the same lines, which means that they have an infinite number of solutions. So I could regraph the second one, but it's going to land right on top of the first one. So they're infinite because everything that I put in will satisfy both equations. All right, 2 more and we're done. So this y-intercept is 3, which is kind of goofy here. Rise 2, run 3, rise 2, run 3, or fall 2, go back 3. So that's the first one. The second one is not in y equals mx plus b. I need to divide by everything by 3. So this one is actually y equals 2/3 x plus 5. Now if you look at these slopes, they're the same slope, but different y-intercepts. So this one starts at 5, rises 2, runs 3. So every dot is going to land kind of like above the other dot, creating a set of railroad tracks, which parallel lines have will never intersect. So this has no solution. And this next one, letter E, need to get this one to be y equals mx plus b. So I'm going to add x to both sides. That would be y equals x plus 1. I can graph that one now. And the slope is 1, rise 1, run 1. And the next one, I need to combine like terms. So this would be y equals x, negative 2 plus 3 is 1. These equations are the same slope, same y-intercept. So this has an infinite number of solutions. The line would land right on top. I failed over and over and over again in my life, and that is why I succeed. Michael Jordan, learning from his mistakes. Have a great day.